Hello everybody, my name is Siringo, and this is my final project presentation for Civil Engineering 4210, Building Physics with Jordan Clark. So the problem I'll be discussing here today is essentially just heating homes in the United States and the different obstacles that this entails. Obviously, heating homes is an expensive task and also comes with high energy costs, and we have more energy efficient methods that have been invented recently, such as solar panels and other methods. However, they have not been able to overtake these old fossil fuel usage methods so far. So the United States still remains one of the largest fossil fuels consumers in the world, and there really seems to not be an end in sight, even with all these new up and coming technologies that are able to mitigate these energy costs and even produce energy at a way more efficient rate. So we will be discussing a solution to this problem and how to make a more energy efficient way to heat the homes in the United States. In addition to this, thousands of Americans are left to survive cruel winters in the United States every single year due to utility shutoffs for lack of payment. So obviously this is outstretched to a poverty problem as well, as those who cannot afford heat are not given the benefit of the doubt and are left to suffer without the proper resources to survive in a winter. And it's a matter that could be life and death. So it's important that the United States maybe looks to solutions that would guarantee heating for all and can provide heat for those who truly need it. And in addition to this, it would also reduce the consumption of fossil fuels and overall reduce the carbon footprint of the country as well. So some of the inefficiencies that come along with this problem is that the United States is obviously a huge manufacturer and of many things essentially, and we have tons of machines that are operating throughout this country throughout the day, whether it's mechanical machines in factories, computers, cars, really any kind of device you want to think is producing heat in some kind of way as it operates. So obviously this heat is produced through countless machines all throughout the day, every day, all throughout the year. And this heat is simply treated as waste because the heat needs to be dissipated and mitigated in order to have the machines function properly. So the heat is disposed of in many different ways. And a lot of time and effort and money goes into figuring out these methods to dispose of heat in more energy efficient ways to have machines run more efficiently and to produce things at a better rate. However, there are those people out there who believe that this heat that is being simply treated and disposed of as waste can be used for better and used for better good for others. So this company leads me to introducing the radiator computer that is introduced by Carnot Computing. Essentially, this is a French company that has invented this radiator that is essentially a computer that can be installed in the home, and it is responsible for just computing all kinds of cloud technology computations all throughout the day. So inherently, as this machine is performing its computations, it is able to produce a massive amount of heat. And essentially, its design is to provide free heat for those who truly need it. So by doing this, the device is installed in the house, it produces its computations, and inherently creates a lot of heat. And this heat is free. It is used to, heat the home. It essentially acts as a space heater. And it's a really good way to cut energy costs, reduce carbon footprint, and it's ecologically efficient. It's also 100% silent, as there's no moving parts within this device. It's totally totally based off of like microprocessors and things like that. And simply, if you need the temperature to be lowered, it can be controlled via smartphone with an app. And lowering the temperature simply just transfers some computations that are being performed by the microprocessors within the computer to another computer and another radiator somewhere to give the heat to someone else. So essentially, there is very little waste with this system, and the heat that's being generated from these computations is being used to actually help those who need it. So how does this really work? Essentially, the radiator is installed in the home and the office, and the device is just constantly performing typical cloud computations for several different devices that are associated with it. So it's just all kinds of cloud technologies that are connected to this, and it's just performing constant computations to, you know, perform its task. It's just a normal computer. So obviously, all these computations are going to generate a lot of heat, and each module integrates 12 to 24 microprocessors whose intensive computer calculations are able to heat the water, which ultimately produce the heat for the room that it's sitting in. And simply disposing of this heat that's being produced by this computer, it's used to heat the homes. So it's acting as a space heater, and like I said before, the temperature can be controlled with an app. So lowering the temperature just transfers the computations to another cloud computer via cloud technology. And this is really efficient because not only is, this computer serving an important purpose, as cloud technologies are crucial in this modern age for a lot of companies and a lot of people to get work done. You're kind of killing two birds with one stone, as these computations are obviously, they take a lot of effort and a lot of computer power. So the heat that's coming off of these is pretty great. Those who have been around a lot of computers at a time can definitely feel that there's definitely some kind of large heat associated with multiple computers running at a time. And on top of that, you have all the fans going within the computer to try to mitigate that heat. So it's good that this heat is just not simply being disposed of, and it's actually being given to other people. It's also important that it can heat the homes for free. I think that's an extremely crucial aspect of this entire thing. In addition to the heat that's produced by this computer, it has additional features that include wireless charging. So if your phone or any other device is just simply placed on top of this radiator, it will charge it without a wire. So that's a pretty cool feature, and it's very helpful for the house as well. It's also a Wi-Fi module, so it does have its own Wi-Fi that it gives off, and this is helpful as well, as Wi-Fi can be expensive, and this is also just kind of, very efficient and very helpful to have. And lastly, it just kind of looks nice, bright, and it provides some kind of light as well. So next we're going to look at the specs for this computer. It's a pretty standard computational computer. It uses a lot of the new high-level processors and operating systems that exist in today's world. It's not too big, as you can see the dimensions here, 34 by 105 by 110 centimeters. It's a pretty standard size radiator if you look at it that way. It doesn't really take up too much space in the home, and it's able to just kind of look pretty normal on the wall. The processor is a pretty new processor, the 24 by AMD Ryzen 3700X. It's very efficient, very powerful computer, able to performing a lot of computations at once, and that's kind of the goal of this thing. As the more computations it's doing, the more it's getting done. Obviously, the computer is going to be able to produce more heat and be a better radiator overall for your household. So the computer performance, we're essentially going to look now at like the heat and what it's able to produce, and what it's able to do for your home. So this technology is obviously optimized for energy efficient output at a high performance level. The computer has to be performing at a high level in order to produce these computations, like I said. So if it's not doing really intense stuff, it's really not going to heat the house. That's why it has to do such a powerful processor and everything. And the focus is also the efficiency of the energy output and producing the free heat as well. So here we can see up to 96% of the computer waste is used by producing hot water. So it's a very efficient machine. Over 95% efficiency is always something that's really beneficial and something you really want to look for in really any device. I mean, a lot of the heating systems that are used in today's homes are well below that 90% number. So to see something that's this efficient, this ecologically friendly, and this cost efficient is a really nice sigh of relief almost for energy efficiency in this modern society. It's also, like I said before, it's completely quiet with no moving parts. There's no need for the fans because we're not trying to get rid of this heat. We're trying to dissipate it into the space around it and to use it for good. So you don't have to worry about it making an obnoxious noise as it's sitting in your house, and it's just nice to have. Based on the optimized cold plates, each module can deliver up to 4 kilowatts of IT power load. It's a lot of power, as you can tell. It's equal to like a space heater. So it's the computer is working really hard, as you can see. PSU fully cooled with water, allowing a density of 6 kilowatts per meter squared. So this heat's obviously used to heat the water pretty efficiently and to a pretty high degree as well. So as you can see, the optimization of this energy, reusing the energy that's being produced by the computer is also about 96% efficiency. So like I said before, this is an extremely efficient machine, and it's able to produce what it needs to do in an efficient manner and complete the task it needs to. So you also have automated control of the power and the frequency of the equipment to adapt to energy and thermal constraints. So the app and everything else that's used to control this device is super simple and straightforward, and it's really not difficult to learn. And it's quick to adapt to the environment in which it sits in. You're not gonna, when you lower the temperature on, you're really not going to have to wait too long to get it to be where you need. It's a extremely friendly device, and it reacts quickly to the instructions that you have for it. So here we're just going to have some calculations, and the table to the right here, it just shows typical efficiencies and outputs by common heaters that are in place in the household. So here we have radiant gas heater, gas convector heater, open decorative gasifier, closed decorative gasifier, and bottled gas heater. So we can see the efficiencies of all these are pretty low, respectively, compared to the computer that we're dealing with here. The 92% is obviously a really good one, and that's something you don't see often, like I said. But the key thing to keep in mind here is that the outputs are 4 kilowatts, 2.5 kilowatts, 3 kilowatts, 5 kilowatts. These are good outputs, but like I said, the efficiency is just not there. And what also comes down to is that these methods are still using gas and fossil fuels. So when you really compare it to the computer, it's just simply not performing at the same level with the efficiencies and the carbon footprint that it's leaving as well. The fossil fuels are still just not great for the environment, and this radiated computer by Carnot is really trying to get away from this and produce the heat and give it to those who need it as well. So if we use the specs on the computer, we can calculate the unit production with the formula here, and just output divided by efficiency, and we can find that the computer has the most efficient output by 4.166. And like I said, even though the bottled gas heater has near efficiency to this at 92%, it would probably yield just around that 4 number. Once again, this is just using gas. So if you just have to outweigh the fact that you don't have to really pay for the heating that comes from the computer, but you do have to pay for this heating that comes from the bottled gas heater, the decision of which one to incorporate in your house is a pretty clear one, if you ask me. So you can also see that it's just far and above the rest of the efficiencies, as the rest of this table really does not compare. And when you start really incorporating the price into it as well, it's almost a no-brainer. And these would be the references that I used for this project. There's a majority of just the websites that you can buy the heater on itself that gives all the specs and everything else that you need for it, as well as the companies that have been marketing Carnot as one of the up-and-coming startups that have been coming to the light recently, and that they have great potential for success in the future. So thank you, everybody, for looking at my presentation. Have a nice day.